This session is on debugging a Java program. We'll take the prime number test program as an example and try to understand the debugging process. So Eclipse provides us a debugger to debug our programs so that we can find out any problems in the program. So I'll first try to run this program. Let's take n is equal to 9 and try to run this program. So it's checking whether a given number is a prime number or not, and it's returning true or false here. So as you see from the program, I'm having n is equal to 9. It's printing, checking if 9 is prime number, and then is prime of n is called. There's a method which takes a number and figures it out whether it is a prime number or not. And if it is a prime number, it is giving true, and if it is not a prime number, it is giving false. So in this case, it is taking 9 and it is giving false. And since it is giving false, that value is collected in p, and p's value is displayed, which is displaying false here. Okay, so let's try to run this for a different number, 5, and see what is the result here. I'm running this thing. I expect 5 to be a prime number, but it is giving me false here. I expected true here, but it's giving false. So there is a problem in this program, in this logic, which we need to find out where this logic went wrong. Because the same logic works fine if I check it for 9, but it is not working when I do it for 5. So we need to identify what would have gone wrong in this logic for calculating the prime number. So debugger is going to really help in this process to identify the issue here. So we'll see how to do a debugging here. First step is we need to put a breakpoint. So breakpoint is nothing but double clicking on any line actually if you want to put a breakpoint. So let's say if I double click on line number 8, I just going to get a blue dot here. That is nothing but the breakpoint. So I can put breakpoint in any lines of this code. So breakpoint basically means is the program is going to stop at this line actually. If you don't put any breakpoint and if you try to debug the application, so you can do debugging by right clicking and say debug as Java application, or you can just click on this bug button which will be debugging the application. So when I click on this debug, as you see, it is just like behaving like a running the program. That is because you don't have any breakpoint here, so the program did not stop you at any point so that you can perform your debugging activities. So the first thing is you need to put a breakpoint so that debugging will not run through the whole thing. It will be stopping at this line. So if I put a debugging in line number 8 and if I perform this debugging, now what is going to happen is it is going to run the code till that line number. So in this case, it is going to execute the code till line number 8. So it has already executed int n is equal to 5. It also executed is the system.out.println. That's why you are seeing the system.out.println appearing here. So but it stopped at line number 8. After stopping, it is also asking some window to confirm whether I can switch the perspective to debugging mode. So Eclipse, if you switch to debugging mode, it is going to give you a lot of views basically, which helps you in the debugging process. So currently you are in the Java perspective. So how do you know that is by looking at it actually. This is the selected perspective. So you are in Java perspective. Now it is asking whether I can switch it into debug perspective. So in Java perspective, you are seeing the package explorer, the program, the task list window, the outline window, the console window. So these are all the views that is given in the Java perspective. But the moment you switch to debug perspective, you will get a different set of views, which is going to be helpful for you in debugging the application. So I'm going to click on switch. So the moment you click on switch, you see there is a debug coming here, and it says you are executing the prime number test program, and the debug line, it is stopping at line number 8, which is the line where we put the debug point. And in the right side, you are having like variables window, breakpoints window, and expressions window. So variables window is the one which we will be mostly seeing, where you see here like all the variables in the main method is listed here. Now it has executed n is equal to 5, so n value is 5 is displayed here. But it is not displaying the p value because it is not yet created. Only when you run this line, only when this line is executed, that is the time the p value gets added to this variable window. So that this is going to help you at runtime when you run the program at any given point of time, what is the value of the variable, which helps you in debugging process. um, so now for performing the debugging itself, we have four options. I would say five options. We have like a resume button, we have a terminate button, we have step into, we have step over, and this is um, disabled as of now. I will explain what is this. This is a step return function. So these are the main five things that you will be looking at when you do a debugging operation. So let's understand each one of them. So first thing, let's try to understand what is terminate button. If I'm in this line number 8, and if I click on this terminate, then what is going to happen is it is not going to execute any line after this line number 8. It is going to just stop here the execution and come out of the program. So if I click on terminate, what is going to happen is it is going to just stop here. It is not going to execute this is prime method. It is not going to print the value of p after this is prime method. So if I click on this, it stops here. The false or true is not going to be printed. Of course, it is not going to even execute this is prime method at all. So that is what terminate means. Terminate means terminate the program at this moment. So don't run any of the any lines after this. So let's debug it again and now see what this step over means, which is the shortcut key for this is F6. So when you do F6 or step over, it is going to go to the next line in the program. That means it is going to execute this line and it is going to go to the next line. So let's click on this step over. Now what is happening here is, you see is prime of n method is executed. That means it is executing all the lines in this method, and then the value is written, the boolean value is written, and that value is assigned to p. So if you just hover this p, you will know p got a value of false, and it is also added to the variable window. So when you do step over, it is going to execute the current line you are in. And the moment here the step over is executing this line. Now if I press the step over again, it is going to execute the system.out.println line. So it is printing the false here. If I put again, it is going to that's the end of this main method. So it is going to complete the program execution. So step over basically executes the given line. Whatever line you are in, it is going to execute that line and come to the next line. Let's do the debugging again. Now let us understand what is step into. Step into means here, instead of stepping over, if I press step into, which is F5, that means I'm going to go into this program, into this method. Actually, I'm going to step into this method. I don't want to execute the method and I don't want to execute this line and go to the next line. I want to get into this method. So for that, if I press F5, I'm going to go into the isPrime method, and here you are going to have your instruction pointer. So now you have now choice to go through one by one. Like you can do a step into or step over. Here that doesn't make any difference because step into, if you give it, there is no method calls here to go inside a method. It is just executing this line. Actually, there is no method call. If there is another method from where it is calling, then it is going to go inside the method. But these are all just lines of code, so it is not going to make any difference if you do F6 or F5. So you can press anything F6 or F5, which is going to execute that line and come to the next line here. In case if this line is having a method, then that makes a difference. It is going to go inside the method if you press step into. Let's now see and figure out the problem, what is happening out here. So look at this. We have the num variable, which is 5, and prime variable, which is true at this point of time. And once you execute this instruction, it is going to become I is going to become 2 here. As you see here, I is equal to 2 here. Now 5%2 is nothing but 1, and you can always try to select this expression and right click on this expression and say inspect. That means it is going to evaluate that expression and give you the value. So if you click on inspect, it's going to, oh, it's, I think I have a issue with the Eclipse and in the Mac OS, so that's the reason it is just disappearing. I think it's a known bug, but when you try to do it, it's going to be working for you. It's going to show up that window, which is going to result a num percentage I is equal to 1 here, because 5 percentage 2 is equal to 1. So at any point of time you can just, select that expression what you wanted to evaluate, and then right click and do an inspect to see the temporary value what will happen when you execute that expression. Now go to the next step. If you want to go to the next step, just press F6 or F5, whatever it is. It, since this was false, it is not, it is the 5 percentage 2 is equal to 1, 1 is not equal to 0, so this block is not executed. So I goes to the next value here. So now currently I is equal to 2. The moment you execute this for loop instruction, it is going to get into I will become 3. And now it is going to check 5 percentage 3. 5 percentage 3 is again going to be 2, and which is not equal to 0. So it is going to go to the next step. So the next step is going to be I is going to change the value to 4. So now 5 percentage 4 is again going to be 1, which is not equal to 0. So it is going to go to the next step. What is the next step? It is going to change I is equal to 5. But at this point of time, I don't expect it to get inside the loop. If you remember, what is the prime number program says is, if I want to calculate whether a 5 is a prime number or not, I need to basically start dividing the number 5 from 2 to 4. But it should not be, you should not divide 5 by 5 itself, because any number is going to be divisible by itself. So if I do 5 percentage 5 equal to 0, then it is not, it is always going to be ending up with 0, which is not the correct way to divide it. So what is the expectation is, this for loop should have terminated when it become I value will become 5. So 5, but it is going inside the for loop. That is the mistake what we had here, and that is the reason all the prime numbers are, even though we pass prime numbers here, it is saying it is not a prime number. So 5 percentage 5 here is going to be 0, and it's making the prime as false instead of true here, and that is causing the problem. So now we identified this, that this is causing the problem. So I'm going to be terminating this, because I don't need to, I can go ahead and fix it now. So how do you fix it? Just remove this equal to, which will not allow for the for the 5 value. It is going to stop when it is becoming 5. So it is going to divide only from 2 to 4 here. So save this program and try to run this. So it is true. So we fixed the problem by means of debugging using Eclipse. So we left over two things. One is the we covered what is a step into function, what is step over, and we also covered what is terminate. Okay. Now let's see the rest of the two. For that, I'm just going to put like few more breakpoints here. So I'm just putting a breakpoint here, and then I'm going to put a breakpoint, and yeah, before that, let's try to debug it, and yeah, I'll put a breakpoint here and then try to debug it. So here, I'm sorry. So it is stopping at the first line itself, because I put the breakpoint here. Now, if I do a resume, what if I do a step over? Basically this line is going to get step over or step into. It is going to get executed this line, and it is going to come to the next line. But if I do a resume, what is going to happen is, it is going to go to the next breakpoint. That means it is going to execute all the lines from the current breakpoint to the next breakpoint, and it is going to stop at the next breakpoint. Now if I click on resume here, what is going to happen? There is no more breakpoint here, so it is going to execute till the end of the program. So resume is going to help you to go between the breakpoints. Like if you have if you know, like if you want to put breakpoints in some places, to logically thinking like at this point of time whether my program is working good, at this point of line whether my program is working good, you can just put the breakpoints and do, instead of going step over each and every line, you can just do a resume, so that it is going to stop at the next breakpoint actually, instead of going through each line by line. So the next thing is, let's say I am putting a breakpoint here. and then try to do a debug here. So now I'm in this breakpoint, and then I can do step over, or I can simply do a resume. So it is going to come to this line. It is executing all the lines between these two breakpoints. It's coming into this line. Now if I do a step over as well, what is going to happen is it is not going to complete this line and go to the next line, because it is going to try to execute this is prime method, but when it is executing, it found a breakpoint, so it is going to stop there. Basically, what a step over means, it is going to execute this line. When it is executing this line, there is a breakpoint found, right? So it is going to stop there whenever you find a breakpoint. So I'm going to click on step over, but still the step over is going to stop at is prime method, because there is a breakpoint I have introduced here. Now I can perform step over, step into all these things, but I felt, I found the problem. I wanted to return to this main method. There I can use, step return. So it is nothing but F7. F7 will basically go to the next step basically. So let's say if I'm taking this breakpoint, and if I if I take this breakpoint out, and if I do, you know still I'll be executing all the I equal to 2, I equal to 3, I equal to 4. But I don't want to execute, I found out the problem. I just want to stop it here and go to the main method, back to the calling method. Now I can press F7, which will skip all the rest of the execution of the iterations, and it basically returns the method to the calling place. That's what F7 means. And now you can press F7, you can press F6, or resume to complete your program execution. So these are the 5 things that we will be using mostly in the when you debug a program: terminate, resume, step into, step over, and then step return. The most important functions are step into and step over, which you will be using most of the time in doing the debugging. Let's see one more thing before we close this. So instead of this program of checking whether a given number is prime or not, let's try to do a generating of prime numbers. For that, what I have to do is, let's say I want to generate the prime numbers starting from 1 to, or I would say 2 to 1000, and I want to check each one is prime number or not. So I say is prime of I. If one is prime, I need to print that number. If one is not prime, I don't need to print that number. So I just wanted to check whether each of the I value, whether it is a prime number or not. If it is a prime number, I'm going to print it. Otherwise, I'm not going to print it. So that way I can generate only the prime numbers. So let's see first whether this program works fine. I can run this. So yes, it is producing numbers, prime numbers starting from 1 to 1000. So these are the prime numbers. Okay, now I'm interested to look at, I wanted to check how, let's say for 193, how this process works, how this logic works. I wanted to see only for 193 how this process works. But it's very difficult to see it for only 193, right? So let's say if I put a breakpoint here, I can put a breakpoint in line number 7, and I try to debug this application. So let's do a debug here. Now I can check what is the I value. It is 2. Okay, I don't want 2, so I can skip it. I can go to the next breakpoint, which means I can do the resume. Resume is going to go to the next breakpoint because it is in the for loop. It is going to come to the next breakpoint, which is again for I is equal to 3. So click on this. I will be 3. I will be 4, 3, 7. But I want to check it for 193. In order to check for 193, I need to click on this resume number of times till this I value becomes 193. Do you understand what I'm saying? So it's going to go through the whole steps till it becomes 193. I have to click on and see to the point where I becomes 193. So this is a tedious way to handle it. But what I wanted to check is only for only when I is equal to 193 here. So what I can do here is I can do a conditional breakpoint. So let me terminate this and right click on this breakpoint and then say breakpoint properties, or you can double click as well. And in this you can say I want to stop this conditionally. I don't want to stop it whenever the execution hits this line. Instead I wanted to stop it whenever it hits a condition basically. So what is the condition I wanted to do here is when I is equal to 193 I need to have this breakpoint, not any other time. So I'm just saying apply and close. Now this is not a normal breakpoint, this is a conditional breakpoint. So it is going to stop. As you see here, it is conditional. In this line, it is showing it is conditional breakpoint. Um, so here, what is going to happen here, when I now debug this, it is not going to stop here for I is equal to 2, I is equal to 3, I is equal to 4 and all these things. It is going to stop, if you see here, it is directly stopping only at I is equal to 193. It has completed the executions from I is equal to 2 to I is equal to 192 and it just stops at I is equal to 193. Now you can now go into use F5 to go into this and check what happens with my logic for just 193 number. So this is particularly useful when you debug any production problems for a particular value. Okay. So the other, so these debugging, whatever we are talking about is going to be working when you are doing the debug in your local machine, or you can point to the development server and do the debugging. But when you give this program to production, when you are deploying this programs to production, when something, let's say some website, Amazon website is running in production and there is a problem, you cannot basically debug Amazon website which is running in production. You can debug your local code, or you can debug your development server or even Intech server, but you cannot really debug a production server. So we don't usually do debugging there because it is going to halt the program and you are going to execute one by one, which is not a right way to do. So usually what we do in our programs is to put a lot of logging statements. So logging statements is nothing but you will be doing a sysout. Actually, it's not sysout. You will be logging into a file basically, a kind of a log file. You will be writing statements into, and there you will be recording the values. For example, in this scenario, what I will do is I will record some values like um, say calculating or checking for I. So, and I can say checking for I, and then here I will say the result basically is prime of I. So now if I put these statements, what will happen is in production, when you run this program, you cannot debug this, but with the help of, if I run this program, you will going to get like check for 999 and it is going to give you false. Like this, you're going to check for 997, it is going to give you true. Like this, it is going to print true or false, and these statements, whatever you have logged into a file, will help you at till what point your program was successful and what point it was failing. So in production system, you don't use system.out.println. You will be using a different way, kind of a log4j or any kind of a logging framework to log your statements into a file actually. And as a production support team, they will be going into the file and check for any errors or any debug statements to understand where the program has really stopped executing. So that is the way to analyze the production logs. And if at all you wanted to debug it, you will be replicating the problem in your lower regions, and then you will be using the Eclipse debugger to debug the code and find out the exact problem where you are facing it.